Welcome. Today we're diving into the fascinating world of cognitive views on learning and memory. Cognitive psychology explores how our minds process information, focusing on the mental activities that help us acquire, store, and retrieve knowledge. Unlike earlier theories that emphasized observable behavior, cognitive perspectives look inside the mind, treating it almost like a computer that encodes, stores, and retrieves data. This approach helps us understand not just what we learn, but how we learn it. As we journey through this topic, we'll see how cognitive theories have shaped modern education and our understanding of memory. Let's begin by exploring what cognition really means and why it matters for learning. Cognition refers to the mental processes involved in gaining knowledge and comprehension. These processes include thinking, knowing, remembering, judging, and problem solving. Cognitive psychologists are interested in how people understand, diagnose, and solve problems, emphasizing the internal processes that occur between stimulus and response. This focus on mental processes sets cognitive psychology apart from behaviorism, which only considers observable action. By understanding cognition, we can better appreciate how learning and memory work together to shape our experiences and abilities. Next, let's look at how cognitive theories emerged and why they became so influential. Cognitive psychology gained prominence in the mid-20th century as researchers grew dissatisfied with the limitations of behaviorism. While behaviorists focused solely on observable behaviors, cognitive psychologists argued that understanding the mind's internal workings was essential. Influential figures like Jean Piaget and Ulrich Neisser helped establish cognitive psychology as a major field. Their work emphasized the importance of mental representations and information processing, paving the way for new theories about learning and memory. This shift marked a turning point in psychology, leading to a deeper understanding of how we think and learn. One of the most influential cognitive models is the information processing model. This model likens the human mind to a computer, suggesting that we process information in stages: encoding, storage, and retrieval. When we encounter new information, we encode it, store it in memory, and later retrieve it when needed. This model helps explain why we sometimes forget things or struggle to recall information. By understanding these stages, educators and learners can develop strategies to improve memory and learning outcomes. Let's break down each stage to see how they work together. Coding is the first step in the information processing model. It involves transforming sensory input into a form that the brain can process and store. This can happen through visual, auditory, or semantic means. For example, when you read a word, you might encode its appearance, sound, or meaning. Effective encoding is crucial for successful learning, as poorly encoded information is less likely to be remembered. Techniques like repetition, association, and visualization can enhance encoding, making it easier to recall information later. Next, we'll see what happens after information is encoded. Once information is encoded, it moves to the storage stage. Storage refers to maintaining information over time, whether for a few seconds or a lifetime. Cognitive psychologists distinguish between different types of memory storage: sensory memory, short-term memory, and long-term memory. Sensory memory holds information briefly, short-term memory retains it for seconds to minutes, and long-term memory stores it for extended periods. The way information is organized and rehearsed in these stages affects how well we remember it. Let's explore these types of memory in more detail. Retrieval is the process of accessing stored information when it's needed. Sometimes retrieval is effortless, like recalling your name, while other times it requires more effort, such as remembering a historical date. Retrieval can be influenced by cues, context, and how well the information was encoded and stored. Forgetting often occurs when retrieval fails, not because the information is lost, but because we can't access it. Understanding retrieval helps us develop better study habits and memory aids. Next, let's look at the different types of memory in more detail. Sensory memory is the briefest form of memory, lasting only a fraction of a second. It acts as a buffer for stimuli received through the senses, such as sights and sounds. This type of memory allows us to experience a continuous flow of information, even though our senses are constantly bombarded. For example, when you see a flash of lightning, sensory memory holds the image just long enough for your brain to process it. Although sensory memory is fleeting, it's essential for filtering and transferring information to short-term memory. Short-term memory, sometimes called working memory, holds information temporarily for analysis and manipulation. It typically lasts for seconds to a minute and can store about 7 items at once. This is the memory you use to remember a phone number just long enough to dial it. Short-term memory is crucial for reasoning, learning, and comprehension. Techniques like chunking, grouping information into meaningful units, can help expand its capacity. Let's see how information moves from short-term to long-term memory. Long-term memory stores information for extended periods, from hours to a lifetime. Unlike short-term memory, its capacity is virtually unlimited. Long-term memory includes facts, experiences, skills, and more. It's divided into explicit conscious and implicit unconscious memory. Explicit memory covers things like facts and events, while implicit memory involves skills and habits. The process of transferring information from short-term to long-term memory is called consolidation, which is strengthened by repetition and meaningful connections. Explicit memory refers to memories we can consciously recall, such as facts or personal experiences. Implicit memory, on the other hand, involves skills and procedures we perform automatically, like riding a bike. Both types are essential for daily functioning, but they operate differently in the brain. Understanding the distinction helps educators tailor learning strategies to different types of content. For example, memorizing vocabulary relies on explicit memory, while learning to play an instrument taps into implicit memory. Schemas are mental frameworks that help us organize and interpret information. They allow us to make sense of new experiences by relating them to what we already know. For example, if you have a schema for dog, you can quickly recognize new breeds as dogs. Schemas play a crucial role in learning, as they influence how we encode, store, and retrieve information. Teachers often use schemas to help students connect new material to prior knowledge, making learning more meaningful and memorable. Structivism is a cognitive theory that emphasizes the active role of learners in building their own understanding. According to this view, learners construct knowledge by integrating new information with existing schemas. Learning is seen as a dynamic process, shaped by experiences and interactions. This approach encourages exploration, questioning, and problem-solving, making learning more engaging and effective. Constructivism has influenced modern teaching methods, promoting activities that foster critical thinking and collaboration. Attention is a key factor in learning and memory. It determines what information gets encoded and stored. Without attention, even the most interesting material may be forgotten. Cognitive psychologists study how we focus on relevant information while filtering out distractions. Techniques like minimizing interruptions and using cues can help improve attention, leading to better learning outcomes. Understanding attention's role helps educators design more effective lessons and environment. Metacognition refers to our awareness and understanding of our own thought processes. It involves monitoring and regulating how we learn, remember, and solve problems. Metacognitive strategies include planning, self-monitoring, and evaluating progress. By developing metacognitive skills, learners become more effective and independent. Teachers can foster metacognition by encouraging students to reflect on their thinking and learning strategies, leading to deeper understanding and better academic performance. Cognitive load theory explains how the amount of information we process at once affects learning. Our working memory has limited capacity, so overloading it can hinder understanding. Effective instruction reduces unnecessary cognitive load by breaking information into manageable chunks and using clear explanations. This theory helps educators design lessons that match students' cognitive abilities, making learning more efficient and less overwhelming. Elaboration involves connecting new information to existing knowledge, making it more meaningful and easier to remember. Deep learning goes beyond memorization, encouraging understanding and application. Techniques like summarizing, questioning, and teaching others promote elaboration and deep learning. These strategies help learners build strong, lasting memories and apply knowledge in new situations. Educators can foster deep learning by designing activities that require analysis, synthesis, and evaluation. Rehearsal is the process of repeating information to keep it in short-term memory or transfer it to long-term memory. There are two main types: maintenance rehearsal, which involves simple repetition, and elaborative rehearsal, which links new information to existing knowledge. Both strategies are useful, but elaborative rehearsal is more effective for long-term retention. Teachers can encourage rehearsal by using activities like flashcards, practice quizzes, and group discussion. Chunking is a strategy that involves grouping information into larger, meaningful units. This technique helps overcome the limitations of short-term memory by reducing the number of items we need to remember. For example, remembering a phone number as 123 456 7890 instead of 10 separate digits. Chunking makes information easier to process and recall, and it's widely used in teaching and learning. By organizing material into chunks, learners can handle more complex information with less effort. Mnemonics are memory aids that use associations, patterns, or imagery to help remember information. Common examples include acronyms, rhymes, and visualization techniques. Mnemonics make learning more engaging and can significantly improve recall, especially for complex or abstract material. Teachers often use mnemonics to help students remember lists, formulas, or vocabulary. By making information more memorable, mnemonics support both short-term and long-term learning. Retrieval practice involves actively recalling information, rather than just reviewing it. This strategy strengthens memory and improves long-term retention. Activities like self-testing, quizzes, and teaching others are effective forms of retrieval practice. Research shows that retrieval practice is more effective than passive review, as it reinforces neural pathways and makes information easier to access in the future. Educators can incorporate retrieval practice into lessons to enhance learning outcomes. Getting is a natural part of memory, often caused by interference from other information. There are two main types: proactive interference, where old information hinders new learning, and retroactive interference, where new information disrupts old memories. Understanding interference helps learners develop strategies to minimize forgetting, such as spacing out study sessions and reviewing material regularly. By managing interference, we can improve memory retention and recall. Spacing effect refers to the finding that information is better remembered when learning is spread out over time, rather than crammed into a single session. Spaced repetition allows for better encoding and consolidation of memories. This principle is widely used in language learning apps and educational programs. By spacing out study sessions, learners can improve long-term retention and reduce forgetting. Context-dependent memory is the idea that we remember information better when we are in the same environment where we learned it. Environmental cues, such as sights, sounds, or even smells, can trigger recall. This principle explains why students sometimes remember material better in the classroom than at home. Teachers can use context-dependent cues to help students retrieve information during tests and real-life situations. State-dependent memory suggests that we recall information better when our physical or emotional state matches the state we were in during learning. For example, if you study while calm, you'll remember better when calm. This principle highlights the importance of managing stress and emotions during learning and testing. By creating positive learning environments, educators can help students optimize memory retrieval. Dual coding theory proposes that information is better remembered when it's presented both visually and verbally. Combining words and images creates two mental representations, making recall easier. This theory supports the use of diagrams, charts, and illustrations in teaching. By engaging multiple senses, dual coding enhances understanding and memory, especially for complex or abstract concepts. Feedback is essential for effective learning and memory. It helps learners identify mistakes, reinforce correct responses, and adjust strategies. Immediate specific feedback is most effective as it allows for quick correction and deeper understanding. Teachers can provide feedback through quizzes, discussions, and one-on-one interactions. By incorporating feedback, learners can monitor progress and make continuous improvement. Transfer of learning refers to applying knowledge or skills learned in one context to new situations. Cognitive theories emphasize the importance of meaningful learning and connections for successful transfer. For example, understanding math concepts can help solve real-world problems. Teachers can promote transfer by encouraging students to relate new material to prior knowledge and practice applying it in different contexts. Scaffolding is a teaching strategy that provides temporary support to help learners achieve new skills or understanding. As students gain competence, the support is gradually removed. Cognitive theories highlight the importance of scaffolding in guiding learners through challenging tasks. Examples include hints, prompts, and step-by-step instructions. Scaffolding helps learners build confidence and independence, leading to deeper learning. Motivation plays a crucial role in cognitive learning and memory. Intrinsic motivation, driven by curiosity and interest, leads to deeper engagement and better retention. Extrinsic motivation, such as rewards or grades, can also influence learning but may not have lasting effects. Cognitive theories suggest that fostering intrinsic motivation through meaningful tasks and autonomy enhances learning outcomes. Self-regulated learning involves setting goals, monitoring progress, and adjusting strategies to achieve success. Cognitive theories emphasize the importance of self-regulation for effective learning and memory. Learners who practice self-regulation are more likely to persist through challenges and achieve their goals. Teachers can support self-regulation by teaching goal setting, time management, and reflection skills. Social cognitive theory, developed by Albert Bandura, emphasizes the role of observation, imitation, and modeling in learning. According to this theory, people learn not only through direct experience but also by watching others. Cognitive processes like attention, retention, and motivation are key factors in observational learning. Social cognitive theory highlights the importance of social interactions and role models in shaping behavior and knowledge. Language is a powerful tool for learning and memory. It allows us to encode, store, and communicate information. Cognitive theories highlight the role of language in shaping thought, organizing knowledge, and facilitating problem-solving. Teachers can use language-rich activities such as discussions and storytelling to enhance learning and memory. By developing language skills, learners can better understand and express complex ideas. Problem-solving is a core aspect of cognitive learning. It involves identifying challenges, generating solutions, and evaluating outcomes. Cognitive theories emphasize the importance of strategies like breaking problems into smaller parts, using analogies, and applying prior knowledge. Developing problem-solving skills helps learners tackle new situations with confidence and creativity. Critical thinking involves analyzing, evaluating, and synthesizing information to make informed decisions. Cognitive theories stress the importance of critical thinking for effective learning and memory. Activities that promote questioning, reasoning, and reflection help learners develop these skills. Teachers can foster critical thinking by encouraging debate, analysis, and evidence-based reasoning. Creativity is the ability to generate new ideas and solutions. Cognitive theories recognize creativity as an essential part of learning and problem-solving. Encouraging creativity involves providing opportunities for exploration, experimentation, and risk-taking. Teachers can foster creativity by designing open-ended tasks and supporting diverse perspectives. Creative thinking enhances memory by making learning more engaging and meaningful. Emotion significantly influences learning and memory. Positive emotions such as interest and excitement enhance attention and retention, while negative emotions like anxiety can hinder performance. Cognitive theories explore how emotions interact with cognitive processes affecting motivation, focus, and recall. Teachers can create supportive environments that foster positive emotions and reduce stress, leading to better learning outcomes. Technology has transformed cognitive learning by providing new tools for information processing, storage, and retrieval. Digital resources, interactive apps, and online platforms support diverse learning styles and promote engagement. Cognitive theories guide the design of educational technology, ensuring it aligns with how the mind works. By integrating technology, educators can enhance learning experiences and support memory development. Every learner is unique, with different cognitive strengths, preferences, and backgrounds. Cognitive theories acknowledge individual differences in memory, attention, and problem-solving. Personalized learning approaches such as adaptive technology and differentiated instruction help meet diverse needs. By recognizing and supporting individual differences, educators can create inclusive environments that maximize learning for all students. Cognitive development refers to the changes in thinking, memory, and problem-solving abilities over time. Theories by Piaget and Vygotsky highlight how children construct knowledge through interaction and experience. Understanding cognitive development helps educators design age-appropriate lessons and support learners at different stages. By aligning instruction with developmental needs, teachers can foster growth and success. Improving memory involves using effective strategies such as organizing information, practicing retrieval, and getting enough rest. Healthy habits like regular exercise, balanced nutrition, and stress management also support cognitive function. By adopting these tips, learners can enhance memory, boost learning, and achieve better outcomes in school and life. Cognitive learning is not without challenges. Distractions, cognitive overload, and lack of motivation can hinder progress. Recognizing these obstacles allows learners and educators to develop strategies for overcoming them. Techniques like goal setting, time management, and mindfulness can help address common challenges and support successful learning. Field of cognitive learning continues to evolve, with new research exploring brain plasticity, artificial intelligence, and personalized education. Advances in neuroscience and technology are deepening our understanding of how learning and memory work. As we move forward, integrating cognitive principles with innovative tools will shape the future of education and lifelong learning. Let's recap what we've learned about cognitive views on learning and memory. Cognitive psychology focuses on mental processes like encoding, storage, and retrieval. Strategies such as rehearsal, chunking, and elaboration enhance memory. Motivation, attention, and emotion play vital roles in learning. By applying cognitive principles, educators and learners can improve outcomes and foster lifelong learning. Cognitive views on learning and memory have revolutionized our understanding of how we acquire and use knowledge. By focusing on mental processes, these theories offer valuable insights for teaching, learning, and personal growth. As research continues, we can look forward to even more effective strategies and tools for unlocking our cognitive potential. Thanks for joining this exploration into the mind's remarkable abilities.